All right, so we put our heading on. So this is what tomorrow's quiz is partially about, okay? Rule to table, this is the first one. And then later on, we're gonna have a rule table graph. Okay, on this one though, we don't know the rule. They didn't give us the rule, they want us to figure out the rule, okay? So we need to get our handy dandy pencil. And to figure out a rule, we need to figure out what's going on vertically. Oops, I have to pick a color. What's going on between the Y's as we go down the list, right? What's going on over and over between the Y's? Because that is going to tell us our growth. Okay, so this what's going on down is our growth. So let's see what our growth is. I went from -8 to -5. What growth is that? Which direction? Is it positive? Is it negative? And how many? To go from -8 to -5. Is it +8? Is it -2? Is it, how much is it changing? It's changing positive, okay? How much positive change is happening? How much positive change is happening? Kevin, refresh your device so that your worksheet you're doing is showing up, please. Yeah, it's changing by a +3 because to go from 8 to 5 is 3, and it was a smaller negative, so it went up by 3. Okay, now we're going to go and look at from -5 to -2. We've got to figure out all of our growths. What's going on? -5 to -2. -5 to -2. Also a +3. So far we're happy because we want the growths to all be the same if we're going to be able to make a rule. Okay, -2 to +1. What do we get? Other people should be looking and responding. Start at -2 and count up till you get to +1. How much did you go? Come on, guys. Someone other than Leslie and Moses and Janessa needs to be answering. This is just counting, guys. Come on. Okay, so that one went +3. From 1 to 4, our last one, also went +3, right? All right, so our growth is consistent, so we're happy. We can write a rule for it. Now, sometimes these don't go by ones. Do you notice that these are going by ones? Let's mark that. I am only going by 1 on each of these jumps, right? So because I'm only going by 1 on each of these jumps, I don't have to worry so much. But if I was going by more than 1 on each of the jumps, I would have to care about the change in Y over the change in X. And we did one of those before. Okay, if I was going by more than 1 jump, so say they were going by 2s, I would have to take the growth of Y divided by the growth of X. But they're not doing that to us, so we're okay. But we should start looking at it that way. Whenever we're trying to find our growth number, growth is equal to, let me get in the box with it, the change of Y divided by the change of x. Okay. So we did this before. We've always gone ahead and done both sides. This is nothing new. We're just linking it a little differently. +1. Okay. Okay. Because that growth is what you put up front with the x. So I have my growth is a change of y, 3, divided by a change of x, 1. Okay. And that's why it's a 3 that's going to go up with our y value. Okay. So our equation starts with a 3x. Okay. Then after we do that, we have to look for the start value. And the start value is always, oops, I should be red, not a text box. The start value is always what's with the 0. Okay. The start value is always what's with the 0. Okay. So for this problem, what is our start value? For this problem, what is our start value? What's with our 0? What's with the 0? Look across from the 0. What's with the 0? That's the start value. Look across from the 0. What's there? Follow the arrow to the start value, -2. Okay, so that means we believe the rule to be 3x minus 2. But we can't just assume that. We have to confirm that. It should be blue. We have to confirm that this was really the rule. Okay. We have to make sure that we got the right rule. And the way we make sure is we work it out on the table. That's why the table gave us some space. Okay, that's why the table gave us some space so that we could go ahead and double check our rule. Yep, I typed the wrong color, so I'm fixing it. No biggie. If you type the wrong color, remember, go fix it. As you see, it's not difficult. Okay. And the way you know what color it is see there was a black square. That meant I was doing the wrong color. Okay, so we have to take that rule. So we're going to copy this rule up to the top of the table. Copy that rule up to the top of the table. And we're going to work it out for each of the numbers to confirm it worked out. Okay. So what is this rule telling me I'm supposed to do? What is that rule telling me I'm supposed to be doing? What's that rule say? What does it mean when we say 3x minus 2? What does that mean when we say 3x minus 2? that we do 3 times the x value and we subtract 2 from it. Yes, thank you, Janessa. So the first row would say 3 parentheses -2 minus 2. That would be the first row. Yes. And I'm going to copy that because I don't want to have to keep writing it over and over. So I can just change the x value and make it quicker. I'm going to put them all in and change the x values and then go back and figure out what they are. Okay. So I saw some of you, for some reason, who that's not what you're doing. You're not actually following the rule. You're making something up for yourself. Okay. And that's not how it works. Okay. When I say 3x minus 2, it means 3 times whatever x value I have. And then I subtract 2 from that answer. 3. Okay. If I had a 5x plus 5, I'd be 5 times the x value. And then, whatever they ask you at the end. Okay. So we're doing our first one. All I did was copy and paste it over. Okay. What is a 3 times a -2? What is a 3 times a -2? -6. So this is saying -6 minus 2 more. Did that get us -8? Did -6 minus 2 more get us -8? Because that's what this is saying, right? -6 minus 2 would be -6 minus 2 more. Is that -8? Yeah. So that one worked. Check. We go to the next one. 3 times -1. What is that? Three times -1. What's that? -3. This says -3 minus 2 more. Did that get us -5? Did it check? Did it check? That -3 minus 2 more makes -5? Is that true? You guys tell me. Is -3 minus 2 more a -5? Is that true? Yes. Okay, so that one checked. So we've got to keep going. Okay, we're on the next one. 3 times 0 makes what? What is 3 times 0? What's 3 times 0? Still 0. So this says 0 take away 2. Does that equal -2? Does that equal -2? Yeah. 0 take away 2 is the definition of -2. So that one checked. Okay, so now we're on the next one. This says 3 times 1, which is what? What is 3 times 1? 3 times 1 is 3. So this says 3 take away 2. Did it check? Three take away 2. Did it check? Yes, it checks. Okay, good. So now we're on our next one. 3 times 2. What does that equal? Three times 2. What do we get? Three times 2, guys, come on. 6. Okay, so this one says 6 minus 2. Did it work? Yes. Yay. So that means that my answer is y equals 3x minus 2. But the things I just did are the things you have to do for your homework. You have to figure out your growth by figuring out your changes. You have to go do the growth division if you need to. So everything I just did, you are doing on your homework one. For some reason, people are not following that direction. They're doing their own thing and they're not getting full credit. So if you want to start getting full credit for your assignment, you're going to start doing the full thing that I ask. Oops, I don't want this. Why was this being so weird? Because I'm trying to pick the line. Okay, I see simple stuff on the left. I see simple stuff on the right. And by simple, I mean that there's not more than 2 things on each side. Okay, there's no extra pluses and minuses, no parentheses, none of that. Okay. There's a way to move this silly thing sometimes. Nope. All right. So now we're going to go find our big zeros, find our big ones, do that stuff. What is our first step all the time? Letters or numbers? What is our first step all the time once it looks like this with 2 things on each side, or 2 on one side and 1 on the other? What's the first step, guys? Letters or numbers? Letters or numbers? Letters, exactly. Always letters first, always. It's been that way for a while. Always letters first. I want to move the sign, he's bugging me. So always letters first. What letter? Am I going to be moving the 4 or the negative x? We always move which letter? The bigger one or the smaller one? So we're comparing to make our big zero, and we have a negative x on one side and we have a 4 on the other. Which one of those should we move? That's right, the smaller one, the negative x. Okay, what does negative x really mean? How many x's are there if it's a negative x? What number is in front of that x that we just don't see, but we know is there? 1. So this is saying negative 1x. How are we going to big zero a negative 1x? What are we going to do? How are we going to big zero a negative 1x? How are we going to big zero a negative 1x? Add an x. Add 1x to both sides. Now, if you need to write it on the side, if you need to write it on the side that has the 4 as adding 1x to remind you, then do that. It's okay. We just don't leave it in the final answer. Okay. If that helps you keep track, then do that. Okay, my big zero happened to the x's. What's left on that side of the equation? What's left on that side of the equation? Now that my big zero happened. What's left on that side of the equation now that the big zeros happened? Three. I have a 3. So I have a 3 and it has to equal. Now we got to look at what happened on the other side. We had a 4x and we added 1x to it. So what do we have now? We had a 4x. We added 1 to it. What do we have now? 5x, exactly. And the minus 12 didn't do anything because we didn't work with numbers yet. Okay, now we got to big zero those numbers. We're looking at a positive 3 and a negative 12, and we have to move the one that's on the side with the x. So which one are we going to move? The 3 or the 12? Which one is on the same side as the x? The 3 or the negative 12? The negative 12. So how are we going to big zero a negative 12? How are we going to big zero a negative 12? Add 12 to both sides, exactly. So we're going to add 12 to the 12. And I'm going to add 12 to the 3. Okay, because I need to big zero the 12. And the way we big zero a negative 12, we do a positive 12 to it. Big zeroed, all gone. All right. So now that we've done the big zero and gotten rid of the 12, what's left on this left-hand side now? Do the math. What would we say the answer to that is? 15, yep. And it has to equal the other side. What's left on the other side once we big zeroed? What's left on the other side once we big zeroed? 5x, yep. Oops, not z, x. Okay, so we're done with our big zeros. There are no more adding, no more subtracting. Adding and subtracting is where we get our big zeros. Now we have to look for our big ones. Our big one is using the number that's in front of the x. Always the number in front of the x, never the other number. Because our goal is to turn that number in front of the x into a big 1. So all that's left is the x. So how am I going to move that 5? What am I going to do? What am I going to do? Division of what? Be specific. What are we dividing by? $15 divided by 5 and 5 divided by 5, exactly. So 15 divided by 5 has to equal, get in the box with it, arrow until you think, it has to equal the 5x divided by the 5. Okay. And if we do that math, what is x going to equal? Because we did the big one, these 5s are gone because 5 divided by 5 is 1. What's left? What are we going to say the answer is? What are we going to say the answer is? X equals 3. Exactly. X equals 3 because 15 divided by 5 is 3. Okay. Now we need to check our answers though. We can't assume that we did the right thing. So we have to double back to the beginning and we have to put that 3 in instead of the x and see if it works out. So 3 minus 3 equals 4 parentheses 3 minus 12. Okay, so we put the 3 in to replace the x's. My PEMDAS says I'm supposed to do multiplying first. What is 4 times 3? I'm doing this 4 times 3 right now. What is 4 times 3? 12. And I notice both sides are going to turn into what? 3 minus 3 and 12 minus 12 turn into what? Three minus 3 and 12 minus 12 become what? 0. So this says 0 equals 0, and we're happy because it checked. So x equals 3 is my final answer for that problem. Okay, let's go do the next one. Do we have a whole bunch of stuff, or do we have just the most we have on any one side is 2? Are we ready for our big zeros and our big ones? Are we ready for our big zeros and our big ones, or do we need to go ahead and simplify first? We have to simplify first. There's extras on both sides. No, so there's no simplifying needed. Okay, there's no simplifying needed. You only have simplifying when there's more than 2 things on any one side. Okay, when there's more than 2 things. The biggest that we have is 2 things. Okay, biggest we have is 2 things. Okay, got to go for the big zeros because we only have pluses and minuses. We don't have a whole bunch of extra. Okay, so to know if we have to simplify, is whether we have more than 2 things on any one of the sides. Okay, that's the only reason we would have to simplify. Okay, but I don't have more than 2 things on any one side. So then I don't have to worry about that. Okay, so I'm going straight to my big zeros and my big ones. I'm putting my line in because that's telling me I have to make sure I jump over. Okay, what do we use first, letters or numbers? Letters, but do I have 2 letters, 1 on each side? No, so I don't have to worry about the letters because I don't have 1 on each side I have to work with. Okay. Okay, so unless I have a letter on both sides, I don't have to worry about the letters. I can go straight for the numbers. So let's go get our numbers. I have a -3 that's with the X, and I have a -12 that's by itself. I need to make a big 0 to clean up the side that has the X. Okay. I need to clean up what's with the X. So which piece needs to be cleaned up? Which piece needs to be cleaned up? Who is moving? The -3 or the -12? Which one's with the X and needs to go? The -3 or the -12? The -3. So we need to big 0 that -3. How are we going to big 0 the -3? What are we going to do? We add 3 to both sides because -3 plus 3 equals 0. For some reason, I'm still seeing people that are adding to positives and subtracting from negatives. You need to be doing the opposite sign of what needs to go away, or it won't work. Okay. Okay. So that big zeroed the 3's. Okay. What's left on the side that had the 3? What's left on the side that had the 3? What got left behind? The 3x, yeah. Okay, so 3x got left behind. What else got left? Then we go jump over and we do the math. -12 plus 3. Are those the same sign? Are those the same sign? -12 plus 3? No. So when they're not the same sign, what math do we do? It's not the same sign. What do? Manny, camera. Okay, if it's not the same sign, we subtract, and then what? Subtract and do what? Get the sign from the bigger number. So are we going to be positive or are we going to be negative? Negative, because 12 is bigger. Okay, and then 12 take away 3 is what? -9. Okay, so we've done our big zeros. Those are done. No more adding and subtracting. As soon as the adding and subtracting are gone, your big zeros are done. Now we have to look at the big one. What is with our X that we need to move out of there? Okay, what is with our X that we need to move out of there? How are we going to make it move? What's with the X? Start there. What's with the X? A +3. So to move the +3, I have to divide both sides by +3. Make sure you're thinking in terms of signs as well as numbers, okay? So this is saying that my 3x divides by 3 has to equal my -9 divided by 3. I'll move it in a second. My 3x divided by 3 has to equal the -9 being divided by 3. Some of you might have seen the whiteouts that I have. You don't have to worry about those. They just were stuff by the other people that made the worksheet that I don't think are important. Talks about points and weird stuff like that. Okay, so my big one happened. It's gone. What's left on that side of the equal sign once those threes are gone? What's left? If I have a 3x and I divide it by 3, what's left? Just the x. And that has to equal the -9 divided by the 3. When we're dividing, if there's a negative, the answer is negative. Doesn't matter if there's the first one's negative or the second one's negative, doesn't matter. If there's 2, it's positive. If there's 1, it's negative. Negative what? -3. Okay, so we have to go check it. Remember, we have to go check it back in the original equation. Okay, so we're replacing the x with that -3. To check if it worked. Because sometimes we make silly mistakes, like right here, we could have said subtract 3. And it would have changed the other side. It would have made it an 18. So -3 times 3 makes what number? -3 times 3 makes what number? -9. And then the equation says -3 and it says equals 12. Okay. This says -9 with -3. Are those the same sign? -9 with -3, same sign. What do we do when it's the same sign? What do we do when it's the same sign? We add in and what? We add them and then do what? Because when they're different, we subtract and the sign is from the bigger. When they're the same, what do we do? Add and what? No, I didn't say to change it from subtract. I didn't say to change it from add. Okay, they are the same sign. We add and do what? There's always a second step. So when we're adding a -9 and a -3, we're going to turn into a positive. Is that what we're going to do? That when we're adding two negatives, they become positive? When did we learn that one? Because I didn't teach you that one. I taught you when they're the same sign, you do what? Add them and do what? Keep the sign, not of the bigger one, just keep the sign. Because if I start at -9 and I go negative more, I'm not changing what I am I? No, -9. No, -9 and -3, -12. So when they're the same sign, we add and keep the sign. When they're two different signs, we subtract and it's a sign of the bigger one. And we talked about that before, so I'm a little confused why we're not quite there with remembering that. Maybe because we've had so many more of the other kind. Subtract and keep the sign of the bigger. Okay, so let's go. Now here's the full deal. We have the rule, we have a table to make, okay? And we have a graph to make, the whole everything. Rule to table to graph. So step 1, we get the table done. What does this mean when we say -2x plus 1? What does it mean we're supposed to do? What does it mean we're supposed to do when we say -2x plus 1. What does that mean? If I stick a number with a letter, what does that mean is happening? It means multiplying, yeah. And then we have to add a 1 to the answer. So it would say -2 times the -2 of the x plus 1 more. And remember, we can highlight, copy, and paste. We're so excited about that. Saves so much time. And then instead of a -2 in parentheses, it's a -1. If my number lock was on, go to the next one. I'm just putting them all in and changing. It would be a 0 in the parentheses because the parentheses is the only part changing because it's standing for the x you're working with. It's standing for the x you're working with. You should not be changing any numbers in the front. You should not be changing what's being added. The only thing that changes is the parentheses because that's the x changing. It's the only piece of the rule that's changing. Okay, now we got to go do the math. -2 times -2. -2 times -2. Now, when I multiply two negatives, they change to positive. So anytime we're multiplying and it's two of the same, they're positive. So it's saying positive what? 2 times 2. Four. And then according to the rule, I have to add one more. So my out, my y value, when I stick in a -x, -2x, is going to be what? What is a 4 plus 1? 5. Okay, we're going to keep going. We're going to repeat it. This says -2 times -1. What is that? -2 times -1. What's that? Just to let you know, some of you are not getting a full participation points because you're making choices not to fully participate. 2, and then we have to add 1 because of the equation. Some of these are super easy. Use your calculator and answer it. So if you're afraid that you're going to get something wrong, use your calculator. Okay. Now, what does that equal? 2 plus 1. Somebody other than Moses and Lily and Janessa and needs to start answering. Okay. Anything times 0 is still the number 0. So what am I going to say my y was when I had an x of 0? What's the y when the x is 0? 1. Yep. Because 0 plus 1 is still 1. Right? Now we're on to the next one. This says -2 times +1. What's that going to get us? -2 times +1? -2. And then the equation says to add 1 to that. That means back up 1 because those are not the same sign. Those are not the same sign. So we're subtracting and keeping the sign of the bigger one. So what would our answer be? Because 1 is positive and 1 is negative, we subtract and keep the sign of the bigger one. So the bigger one was negative, and 2 minus 1 is 1. Okay. Last one. -2 times 2. What do we get? -4. And we have to back up 1. So somebody other than Leslie, Moses, Lily, Janessa. What are we going to get? Because that's two different signs. So I know I'm supposed to subtract and keep the sign of the bigger one. So what's that going to be? What are we going to get? Use the calculator if you have to. -4, add 1 back. What do we get? -3. Okay. So now we've got our x's and our y's, and we're going to make our coordinates. Okay, first coordinate, parentheses, -2, comma 5. Parentheses, -1, comma 3. Okay, so all I'm doing is changing the table into the coordinates we know they are. Because we need to use them for the graph. Right? Those are my 5 points. When x was -2, y was 5. When x was -1, y is 3, and so on. So I just turned the table into the coordinates that I know them to be. So I can go do my graph. Okay, step 1 for my graph is I have to figure out my scale. Now, my scale is my biggest x to my smallest x. So how many lines do we have to work with? Let's look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I have 10 in all the directions. Do I have to go by ones if I have 10 in all directions? Do I have to use every single little tick mark? Or can I skip some tick marks and do 1 and skip some tick marks and do 2? Or skip some tick marks and say 4 and skip some tick marks and say 8. So I have to go up to +2, down to -2. How much do we want to do? Do we want to go and use every single line and make it teeny tiny? Or do we want to be skipping so we can have more space? Does it matter? No. What matters is that you label it. So I'm going to go 1, 2, 3, and the fourth one is going to be my number 1. And then 1, 2, 3, 4, and the next one's going to be the number 2. So my x's, which I have to label for tomorrow's quiz, my x's are going out to 2. And then I have to do whatever I do on the right side, I have to do on the left. So 1, 2, 3, 4. There's 1. 1, 2, 3, 4. There's my 2. But is that +2 or -2 on the left side? -2. So I have to say -2. So the reader knows what the tick marks I drew in stand for. Okay, then we got to go top to bottom. I have to be able to go up to a +5 and down to a -3, but I have 10 spaces. So do I have to use every single line, or can I skip lines to make it bigger? Do I have enough space to do skip lines and still with 10 spaces get to 5? Yeah, we do. So 1 tick mark, skip. 2 tick mark, skip. Okay, so I've made how many tick marks? How many did I draw in? How many did I draw in? Going up. 5. So that means my 5 is how far I went, and that's for my y's. Going down, same way. skip one, skip one, skip one, right? But when I get to the bottom, and am I going to say 5 if I'm going downward? What am I going to say down here at the bottom?
It's closed. It's closed.
I went, how many tick marks down? And when I go down, what's my sign? -5. All right, so let's go get, I changed my dot to about a 4. We're going to go put our dots on the graph now. When x is -2, y is +5. So -2, +5. -1, +3. So 1, 2, 3. It doesn't mean 3 lines, it means 3 tick marks. 2 is +1, or 0 is +1. I said that wrong. 1 is -1. And 2 is -3 tick marks. Okay, and we're going to go put our coordinates on. So we're going over to our list that we made, and we're going to highlight the one we need. Here's my first one. That was the first dot I made. And I'm actually going to change this to be red so I can see it a little better. Maybe even move them up a little bit. Okay, then I go get my second one. And I put it next to the second dot. Now I'm putting it on the left side of the dot because the line is there. And if I put it on the right side, it's going to bump into the y-axis, and I don't want that. And I'm trying to set it up so the numbers don't have a line through them. Let's go get our third one. That's why we made them. So all we have to do is copy and paste them where we need them later. He's not too bad. I'm going to shift him up a little bit so that the numbers aren't got lines through them. Anybody have questions about how this works? Oops, I did the wrong thing. I need this one. Isn't that funny? Oh, I need to undo the fill. When in doubt, get your eraser. No? Charlie, figure out how I can fix that. I don't like having the white. Is there a spot for no fill? Let me see. Oh, right there. Okay. If I go here, maybe? Is it going to put my lines back? Forget it. I'm not going to worry about it. That actually is not so bad because then it makes it stand out a little bit. So let's go do that. Fill it with white. Look how much better that is. By accident, I found something cool, huh? Definitely makes the coordinates stand out a little better. Okay, we have our last one to go do. Copy it over. So what we've just gotten done is exactly what's on tomorrow's quiz. Doing a table, completing a table, and then taking it to the graph. Okay, and labeling the graph and your scale of your graph and all that stuff we just got done. I think you have 4 of them. Okay. Now, is this done? Are we done? Did we finish everything we needed to for it? No. What did we not do yet? What did we not do yet? We've got to connect the points. So we connect from the top. We have to connect all the way from one end of the graph to the other. We do not stop until we hit the other side. Okay, your graph has to extend completely. And with that in there, I don't like where this one's at. So I'm going to move him a little bit so he doesn't interfere with the graph line. Okay. So what we just did there is exactly what you have to do multiple times on tomorrow's quiz. Okay, now we're reviewing what we did before. We need to evaluate the expressions. That's not a big deal. That's telling me my x's are -2 and my y's are 3. So I'm rewriting and putting those into their spots. So where I see an x, I'm putting the -2. Where I see the y, I'm putting the +3. Everything else, including the parentheses and everything, I'm leaving alone. Okay, everybody okay with that? And then we got to go do the math. According to PEMDAS, according to our order of operations, what piece of this do I have to do first? According to our order of operations, what piece of this do I have to do first? What part of this do I have to do first according to my order of operations? Because right now, all I did was substitute the numbers in. I haven't done anything yet. What piece do I do first math-wise? What piece do I do first according to the rules? The parentheses. Well, I see lots of parentheses. Which one would be the parentheses, though, for this situation? What part of this is a parentheses, really? Remember what I talked about. The parentheses they're talking about in the order of operations is a parentheses with adding and subtracting. We do not count the parentheses of the multiplying as parentheses. The parentheses they're talking about in order of operations has to have adds and subtracts in it. And I see that's this +7 part. The 6 is not changing. The -2 is not changing. The subtracting doesn't change. The parentheses doesn't change. What does change is this 3 times 3 makes what? 3 times 3 makes what? 9. And then the add 7 doesn't change. Now we're ready to clean up that parentheses. So what is it going to say? The 6 doesn't change. We haven't gotten to that yet. We're just doing the parentheses step. 9 plus 7. We're now ready to clean up that parentheses. 9 plus 7. What do we get? Come on. Use your calculators if you have to. 16. Okay, now we've cleaned up the parentheses. That's the first step in order of operations. What's the next step of order of operations? Exponents. Do you see exponents? Do we see exponents? Do we see any exponents in our question? No. So then we move on to the multiply or divide, depending on what you see from left to right. I see a multiply. I see a 6 times a -2. What do we get? 6 times a -2. What do we get? -12. Yep. Oops, I forgot the negative sign. And it says to subtract 16 from that. So we're ready to get our final answer of what? They're the same sign. So what are we supposed to do? They're the same sign. So what are we supposed to do? Add them and do what? Keep the sign, not subtract and keep the sign. Okay. Add and keep the sign they already are. So if there's two positives, we keep the positive. If there's two negatives, we keep the negative. Okay. If they're different signs, we subtract and it's the sign for the bigger one. But these are both the same sign. So we're going to add them and keep the sign they already have. So what would the final answer be? Exactly, negative 28. Okay, it's not x equals negative 20, it's just negative 28. Okay, we're going to go do it again. They're saying x is negative 1, so we're going to put it in. 3 parentheses, negative 1, shift 6 to the second power, arrow off, minus 5 times negative 1 minus 4. All I did was put the negative 1 in everywhere I saw an x. That's all I've done. Okay, does this problem have a parentheses in it? Does this problem have a parentheses in it? What did I say? Parentheses have to have adding and subtracting in them, inside the parentheses. So do we have that in this problem? Adding and subtracting inside the, no. So do we have the parentheses? No. So what's the next step we have to do if there's no parentheses in our problem? According to our order of operations, what would be step 2 then? Because step 1, we don't need to worry about. There is no adding and subtracting in parentheses. Exponents. Okay, so that exponent says 2. That does not mean times by 2. It means take 2 of yourself and multiply them. So that's 3 times negative 1 times negative 1. Okay, so I'm actually going to write it that way because some people keep forgetting what that exponent means. Okay, so what I did was I took this exponent and I spread it out so I could do the math. What's a negative 1 times a negative 1? Negative times negative makes what? When we multiply and it's 2 of the same sign, what do we get? We get a positive. Okay, so 1 times 1 is what? What's 1 times 1? Because the 2 negatives make a positive 1. Okay, now, what if it had been negative 3 to the second power? So we're going to go up here and we're going to do a little practice. What if I had negative 3 to the second power? What would I get? Negative 3 times negative 3 makes what? What did we decide? Negative times negative makes what? Because remember that 2 in the sky means times itself. So that's the same thing as saying negative 3 times negative 3. So some of you need to fix your ideas about this, the power of 2, because a lot of you are doing the times 2, which is an error. Okay, so I now have 3 times 1 to work with because we moved on from exponents. We're on to multiply and divide like we read. Okay, so we have a 3 times 1. What's that? So this is just a little reminder up here about how the exponents work. 3 times 1. 3. -5 times -1. Make sure you're using signs. +5. And then subtract 4 is in the problem, right? Okay. So now we're going to combine. Adds and subtracts like we read the problem. So what's coming first? 5. 3 plus 5. What do we get? 8. So this says 8 subtracting 4 for our final answer of what? 4. Okay, so this one, there's one of our final answers. I'm going to change the size of that in a second. I forgot to change it back after I used it. And here's our other final answer. Okay. And I'm going to erase that line because it was not the size I wanted. Okay. Evaluate does not say x equals 2. There's no x's, there's no y's. It's just figure out the number based on what we tell you. Okay, so now we have Emily is typing 731 words a minute. Jesus is doing 731 words in 17 minutes. Jesus is doing 835 words in 20 minutes. So we have to figure out what their unit rate is. Remember, unit rate is division. This is the part that I didn't want you guys to see. It talks about points and weird stuff like that. So if you want to write it out, you can. I don't like seeing it, so I'm writing it out. Okay, so we have to take Emily first. Let's do Emily. Oops. To find Emily's unit rate, we're going to take her 731 words and we're going to divide it by 17 minutes because that's how long it took her to do that. So use your calculator. What do we get? If I take 731 and I divide it by 17, what do I get? And then we have to take Jesus and divide him by his 20 minutes. So use your calculators. What is Emily's number? Including the decimal. Just read what's in the calculator. What's the calculator tell me? 731 divided by 17 is what? Exactly 43? No decimals, right? Okay. Then we go do the 835 and we divide it by 20. And what do we get? Come on. What do we get, guys? Use your calculator. Okay, 41.75. Okay, so then we would go over here. Emily does 43 words per minute. And Jesus is doing 41.75 words per minute. Okay. This is supposed to say who is faster, but for some reason the text box disappeared when I went and saved it, so we're going to type it in. faster. Explain why. Okay. I don't know where it went. Not worried about it. Okay, so who is faster? We're going to circle one of these answers. Who is faster? Oops, this should not be that color. Emily is faster. So we're going to circle Emily. I'm going to circle Emily. Because Emily was faster. We're circling Emily. And then we're explaining why we're circling Emily. Okay. So we circled Emily. What are we going to say is the reason why we've picked Emily? Using what we just learned in part A, use some of that information in this answer so that we can justify why we picked Emily. So, why are we saying that Emily is faster again? Emily is faster, spell the word faster correctly, because why? Use what we just figured out in part A in this answer. There's no reading. This is typing words. That's why it says words per minute. And it doesn't have anything to do with more pages. Sort of. It's not just more pages, because she read 731 and she typed 731. He's typed 835. Why isn't he bigger? Use your information from part A. Use all the words and everything we put in part A in this answer. She types what? What is her typing speed? What is her typing speed? We just figured it out in part A. What's her typing speed? $43 what? 43 words per minute. But Jesus types what? So that's why they had you do part A. So you were ready to use the information in part B. What's Jesus type? What's he at? Jesus types what? Emily types 43 words per minute. Jesus types 41.75 words per minute. Okay. So that was the whole point of part A. So you had your answer for the reason for part B. We got it? Okay. We're going to simplify these. We can use color coding or we can use table. We could use either color coding or table. Which do we want to use? Or do we want to use both? Which do we like better? Color coding or table or both? Both. Okay, so let's go make our table really quick. I'm looking through here. I see X's and I see Y's, X squareds, Y squareds, and numbers. I don't see any regular X's. I don't see any regular Y's. So I'm only going to be putting together X to the second power, Y to the second power, and number, because those are the only three things that are showing up in my question. I don't have to worry about the plain X's. I don't have to worry about the plain Y's. I just am worried what I have in my question. Okay. Okay, you do not need everything. You just need what you have for your question. Okay, so I've made my table, so now I'm going to go color code. You can do color coding, you can do table, or you can do both. We're actually doing both. Okay, here's my x squareds. They go with my x squared. There's another x squared. Here's a third x squared. So we're doing both color coding and. Then I see that there's a y squared, and I see a y squared. So he's going to be pink. Does it matter what colors we pick? No. Just that you keep it consistent. Whatever you pick in your question, you pick for your table, or vice versa. Okay. So I'm going to go put my x squareds down in my x squared column. So I got to make these smaller though, because I have to fit 3 of them. I have a 3x to the second power. I have a negative 8x to the second power. So you can use color coding, or you can use table, or you can do both. We're doing both because someone had asked for both. And then I have another 3x to the second power. But I'm going to move out of these words in a second. Okay, and then when I look at my y's, I have a negative y to the second power. That's this first pink one. And then a positive y to the second power. And this one here should say positive because it was a positive in the question. Make sure you're bringing the sign over. Okay, and then our numbers say a positive 10, positive 10, but I want to change you back to blue. And it says that I have a negative 8. Okay, so I color coded it and I put it in the table, and now I'm going to pull that table together. If I go adding down my table, I have a 3x minus an 8x. What would I get? A 3x minus an 8x? What do we get? What does 3x minus 8x get us? Come on, guys. What's 3x minus 8x get us? Okay, so you are finishing parts A and B of that. I wanted to remind you about this one because you are going to be responsible for number 7, A and B. Remember, this is the cross multiply one. You got to do that first. Okay, so I am expecting that you will have finished part A, part B of 6, part A and B of 7, and you need to have that finished before 12 noon today. And finish it and turn it in. If you don't finish it, then your maximum score, if you did everything I did, would be a 50%. Do we understand? Any questions about what I'm expecting? So you will have to go back and look at question and chapter 1 and remind yourself how to do these cross multiply ones. I didn't cross out part A and part B. That's the reminder that these are cross multiplies. That's the reminder that those are cross multiplies. That is not, you don't do them. That is, you need to cross multiply. Got it? So I'm expecting 6A to be finished, 6B to be done, 7A to be done, 7B to be done, Those lines mean you have to cross multiply. So you're going to need to go back to chapter 1 where we did the cross multiplying before. And look how that happens. Any questions? Okay, when is this due by at the latest? When is this due by at the latest? Yes, 12 noon today. Okay, have a nice day.